Okay, coming to question 31. Well, this is a kind of question to which you either know the answer or you don't. This is not something that you can actually sit and solve in the exam. Well, what we have been given with is a function u which is differentiable. This is from r squared to r squared and given with a couple of conditions which the function u satisfies. Well, if you look at this closely, these are nothing but u can be understood to be a utility function of two variables, that is two roots. And this particular first condition, let's say f1, represents the ratio of marginal rates of substitution of u with respect to x1 and x2 equated with the price ratio. This is something that you usually do when you are maximizing utility, either constrained or unconstrained. And in this case, it happens to be constrained because the income is given to be w. And the second function f2 is nothing but the binding income constraint, budget constraint, let's say. So, and you're asked with what conditions do we need more on u apart from being differentiable for x1 and x2, the functions x1 and x2 which are also the choice functions or let's say demand functions, for them to be continuous. Here we need to understand implicit function theorem and also its application, and it's just a direct application of implicit function theorem once you know what implicit function theorem is. Well, implicit function theorem gives us a way of finding the choice functions. So since we have f1 and f2 here, for x1 and x2 to be continuously differentiable, what we need to do is find the Jacobian matrix J. Here J is defined by, I'll write here J, since there are just two variables here, I'll write for two variables, that is del f1 by del x1, that is partially differentiating this function f1 with respect to the first variable, and similarly del f1 by del x2 with the second variable. And so it is the case for second function, which is the budget constraint, del f2 by del x1 and del f2 by del x2. So this matrix can be similarly expanded for n variable whenever that is required. So what we need is for functions x1 and x2 to exist and be continuously differentiable, we need the Jacobian matrix to be non-singular. And in this case, if we substitute for f1 this particular equation and for f2 this particular equation, you can easily find out that what is given to us in the question, that particular matrix is obtained and that is non-singular. And with this, that is the additional condition that we must impose on this function u for x1 and x2 to be continuous and strictly positive.